This is lesson 10.4, use square roots to solve quadratic equations. You should be on page 652. To use square roots to solve a quadratic equation in the form ax squared plus c equals 0, first isolate x squared on one side to obtain x squared equals d. Now, again, that looks kind of complicated. This is all it's telling you. This technique that you're going to learn only works for standard form equations when the b value is 0. Do you notice there's no b value here, so b is 0. This technique is great when we have standard form quadratics and b is 0. This is one method for solving quadratics where you don't get everything on one side, 0 on the other. You just want to get x squared on one side and put the numerical amount on the other side. So that's what this means. This is just saying when you have this, get x squared by itself on one side of the equation. And then use the information in this key concept box about the solutions of your equation to solve. So let's take a look at what this key concept box says. When you solve x squared equals d by taking square roots, three scenarios can come up. Here's the first scenario, and let me highlight it. If the value d is bigger than 0, then that means that your problem will have two solutions to it. So, for example, when you look at, let me just make up one real quick. So if I had x squared equals 8, 8's a positive amount, I'm going to get two solutions to that problem. Okay? Here's the next scenario. If the d value is 0, then the problem only has one solution. The answer is going to be 0. And there's one more scenario that could happen. If the d value is negative, then the problem would have no solution. Okay? So when you get x squared by itself, if x squared equals a positive amount, like you see in yellow, you get two solutions. If x squared equals 0, you get one solution, 0. And if you have x squared by itself equaling a negative, you'd have no solutions. Okay? Let's actually do these few problems here. Let's solve the equation. So I got to get x squared by itself, so I'm going to divide each side by 2. And when I do that, I will get to here, x squared equals 4. And then what you need to do is you square root each side of the problem. To get rid of a square, you got to take a square root. Now, a square root cancels a square. That's why they call this lesson, and let me move it, that's why they call the lesson using square roots to solve the quadratic. See, we're using a square root in this sample. So when you take the square root, you get two solutions. The square root of 4 is 2, but it could also equal negative 2. So we're going to end up with two solutions to the problem. Okay? Let's do this next sample. I got to get m squared by itself. So I am going to add 18 to each side, which would give me m squared equals 0. And remember, if we have our variable squared equaling 0, we get one solution. This is going to equal 0 then. If you square root each side, the square root of 0 is 0. So m will equal 0. And then here's another problem. I got to get b squared by itself, so I will take away 12 from each side, which gets me b squared equals negative 7. Remember, that's the third scenario here. If I have a negative value, then this would have no solution to it. Simplifying square roots. In cases where you need to take the square root of a fraction whose numerator and denominator are perfect squares, the radical can be written as a fraction. So now your calculator can definitely assist you with this. For example, actually let me do that up here with you. For example, let's take this problem. I got to get z squared isolated, so I divide each side by 4, which gives me 9/4, and I got to square root each side. And if you take the square root of 9/4 in your calculator, it's going to give you plus or minus 1.5. But if you go ahead and hit the math key, fraction, it could make it into the fractional amount 3/2, plus or minus 3/2. I would say it's probably a good idea to try to write it in fractional form if you can. I don't know that I wouldn't mark it wrong if you kept it as a decimal, but sometimes having that fractional amount is actually more convenient. So remember, the math key on your calculator can do that for you. Approximating square roots. In cases where the number in the equation x squared equals d, in the event that this number is not a perfect square, or a fraction whose numerator and denominator are not perfect squares, you need to approximate the square root. A calculator can be used. Now, you can use your calculator on these anyway. So let's talk about solving this problem. I got to get x squared by itself, so I'm going to add 11 to each side first, which would give me 3x squared equals 18. And then I can divide each side by 3, which would give me, and you can see it here, x squared equals 6. Now, to get rid of the square, I have to square root each side. So if I take the square root of 6, I'm going to get positive or negative. Now, if you put it in your calculator, let's do. So I am taking the square root of 6, and I'm getting that. Well, you can see in the book they asked me to round this to the 100th. So let's look at that real quick. If I want to round this to the 100th would be up to here. The 9 is telling me to round this 4 up, so I would get 2.45, which is why the book is putting plus or minus 2.45 as the answer. They wanted me to round this to the 100th. Okay? Why don't you try? Go ahead and solve in your notes. Go ahead, do numbers 2, 5, and 8. Pause the video, and then we can look at if you're getting those correct. Okay, I'm back. Question 2. We need to take away 12 from each side, which would give me 5w squared equals negative 20. I would divide each side by 5. You notice how I am getting a square equaling a negative amount. Well, if a square is equaling a negative, that's a no solution. So I just wrote NS, no solution to that. Let's go to 5. I would have to divide each side by 9 first, which would give me m squared equals 100 over 9, and I can square root each side, and this works out actually into a fractional amount because 109 are perfect squares. I'd get plus or minus 10/3 for number 5. And then number 8, I'd have to add 1 to each side first, which would give me 3k squared equals 1. Then I divide each side by 3, so k squared would equal 1/3. And then I would square root each side, and this doesn't work out perfect, so I'm going to, you notice the directions, round to the 100th if I have to, plus or minus 0.58 in that case. This technique also works nice when you have a problem that looks like a binomial being squared, like this particular example, okay? When we have that, we can use this technique to solve these too. So the first thing would be to get the square isolated. So we're going to divide each side by 6 first, which cancels the 6's. So I would have x minus 4 squared on the left and 7 on the right. Now, how do I get rid of the square outside the parentheses? Well, I got to take the square root of that on each side. Don't forget to do the same thing to each side. So the square root and the square cancel, so I have x minus 4 on the left, and I have positive or negative square root 7 on the right. And now I have to solve, I got to get x by itself, so I would add 4 to each side. So I'm going to get 2 answers to this problem. Let me write them down over here. I would be getting positive square root of 7 plus 4. And you can see that would equal about 6.65. But then I would also get negative square root of 7 plus 4. And when you put that in your calculator, you'd get about 1.35. So this using square roots technique also works nice on problems that have that format. Okay? Let's look at a multi-step problem. Now this can work out nice on the vertical motion model problems if b is 0, which this type of problem is. So During an ice hockey game, a remote-controlled blimp flies above the crowd and drops numbered table tennis balls. The number on the ball corresponds to a prize. Use the information in the diagram to find the amount of time the ball is in the air. Now you notice the blimp, I put it in pink, is 45 feet in the air. The person catches, you can see the blimp is dropping a ball at 45 feet, and the person catches at 17 feet in the air. So I'm using vertical motion. So here's the model. Okay, the 45 is going to be plugged in for the starting height. 17 is the height that the ball is being catched, and when the ball is dropped, it's starting from a dead stop. So V, you notice, is 0, which means the middle term disappears. So do you notice? This is a problem with no B value. These are great to solve using the square root technique. So I got to take away 45 from each side first, which gives me negative 28 equals negative 16t squared. Then I can divide each side by negative 16. And that gives me t squared on the right, and negative over negative is positive, 28/16 on the left. I can square root each side. So the square root of 28/16, these are not both perfect squares, works out to a positive 1.32 and also negative 1.32. But let's think for a minute. Can I have a negative answer? And no, that's why they're using the positive. The ball must have been in the air about 1.32 seconds. Before we quit the video, let's have you try one of these. Go ahead and solve this using the square root technique. Okay, I'm back. So step 1, divide each side by 2, which would give you x minus 2 squared equals 9. Then you have to square root each side, which would give you x minus 2 equals, well, the square root of 9 would be plus or minus 3. Then I have to add 2 to each side. That's going to give me two answers. It's going to give me positive 3 plus 2 or negative 3 plus 2, which works out to 5 or negative 1. Okay, I'm going to pause the video there. If you have questions, make sure you ask in class.